Alright, here we're going to look at alkanes in particular. This is going to be 25.3. These are my single bonded carbon chains. Okay, they are very widely known. They're methane, propane, butane, things like that. They're always going to have some kind of formula if they have C to whatever the number is. If you take 2 times that amount plus 2, that's how many hydrogens you should have on that particular structure. And there are different ways to write these particular structures. You need to write these down in your notes here. Okay, there are the kind of regular formulas for these with the kind of like the totals. We have a CH4, C2H6, and C4H10. Then you have these structural formulas, which would be with everything right now. Remember, carbon always has 4 bonds. Okay, so all these carbons always have 4 lines coming off of them. So if I have 1 carbon, 4 hydrogens, that's how they connect. 2 carbons, 6 hydrogens, 4 carbons, 10 hydrogens. Those are structural formulas. These are kind of condensed structural formulas. Alright, I write them as CH3, CH3. It's a lot easier to write this out than it is to write all of those hydrogens and all of those lines. This is implying that these 2 H's, or these 3 H's are off of this carbon, and these 2 carbons are bonded together. Everything that's written in a row is bonded to whatever is before it, unless it's an H, okay, or a Br or something like that that's directly next to a C. That means that it is coming off of the C. Okay, so here I have CH3, CH2, CH2, CH3 because that's what I have right above it and it follows. You can also write another kind of condensed formula where I can kind of group these 2 together because I have 2 of the same thing in a row. They do this a lot for big polymer chains. We have tons of CH2s or tons of different carbons that are all in a chain and they're all the same. So these are all CH2s, so all I do is I put a 2 there. The last one we call like a line drawing, okay, and these are also used for long carbon chains, okay. Each kind of spot where, or end of a line is a carbon. So I have this carbon here, then I have another carbon, then I have another carbon, then I have another carbon. Each one of those is a carbon, and you're just supposed to imply that off of there you're going to have 3 H's there, 2 H's there, 2 H's there, and 2 H's there. So those are line drawings. A lot of times those are easy if I have, say, a bunch of carbons there and then I have a double bond somewhere. Alright, so it looks kind of like that benzene ring or the aromatic ring that I drew a picture of earlier. So these are line drawings. Okay, this one here is not an example of that one. Alright. Okay. Now we have some basic naming rules. Okay, the way you name these long carbon chains, and there are 5 rules here. Alright, find the longest chain and use it as the base name for the compound. It's not always a straight line though. Find the longest chain, use it as the base name. Okay, number 2, groups attached to the main chain are called substituents. So something that's in place of an H off of this main chain is called a substituent. Alright, we start numbering the carbons in the longest chain, starting with the end closest to a substituent. Number 4, you give the name and location of each substituent. And these substituents always end in YL. So it's going to be like methyl, ethyl, propyl. They're going to end in a YL if it is off of the main chain. Okay? If you have 2 or more substituents that are present, you list them in alphabetical order. Okay? If you have 2 of them, you have dimethyl. If you have 3 of the same substituent, it's tri. If you have 4, it's tetra. Okay, or not tetra, sorry, butyl. Alright, but is 4. And then they are numbered accordingly, like we talked about a second ago. And keep in mind the first letter of the name is always capitalized. So these rules may make absolutely no sense because we haven't looked at an example yet. And I haven't talked about what these actual prefixes are for these different groups. Okay. These different chains, how I give names to these long carbon chains. So for right now, just hang with me, copy down these rules, okay? You don't have to copy down every single thing after it. You don't have enough room for that. Just copy down the basic bold things there. So here are the prefixes that you will use. Okay, prefixes that are used to show the number of carbons in a chain. If I had just CH4, we call that methane. But anything that has a 1 carbon in it off of a main chain is called a methyl group. Notice how I changed that ane to a YL, so it comes off of the side of a group. Ethane is 2 carbons, propane is 3 carbons, so propane is C3H8. But if I have a propyl group, Okay, that means I have some long chain of carbons, okay, and then off of that main chain I have 3 carbons. Okay, this would be a propyl group. Okay, whereas propane is C3H8, a propyl group is kind of lost a carbon there, okay, or lost a hydrogen there, and it's connected to this main chain of however many carbons I have there. 4 is butane, 5 is pentane, 6 is hexane, heptane, and we have octane, nonane, and decane. Those are all off of a bigger main chain. You give them a YL. If it's just that's how many carbons I have in that group, I would call that with an ane. Okay, so if I just have, like our examples we had back here, okay, this right here, CH3, that is 2 carbons, we would call that ethane. This is methane, that's ethane. This is 4 carbons, we call that butane. We're going to also talk for a second about isomers, and then we'll get into some naming practice, okay? A structural isomer is a formula with the same molecular formula, but written with a different structure. So it has the same basic number. Okay, so for example, these two both have 4 carbons. Okay, they're both C4H10, but they're going to look differently. I mean, look at this. One is a long chain, one has a branch in it. Okay, so this is butane, this is isobutane, and we're going to look at these names for these different ones here in a second. So structural isomers have different structures for the same basic formula. These different names we give things are based off of the type of carbon it is. Okay, primary means it's bonded to 1 carbon. We call these iso if it's a substituent, ISO. Okay, if you have a secondary carbon that's bonded to 2 carbons, we call that sec. 3 carbons, tertiary or tert, and 4 carbons is a quaternary carbon, and something bonded to 4 carbons isn't going to be bonded or isn't going to be a substituent, so it doesn't have like an ending. Okay, so this guy right here on the end is a primary carbon. This one here is a secondary carbon because it's connected to this carbon here and this carbon there. That's a secondary carbon. This carbon down here is connected to 3 carbons, so that's a tertiary carbon. All right. So these different types of carbons are going to give us different names for these branches that you're going to look at off of a main chain of carbons. It's always a big carbon chain, and then you look at what's off of that main chain, and then those things have special names. Okay? I mean, nice for everything was just propane or butane. And again, remember the ane, A-N-E, it means that it's all single bonds. Okay, alkyl groups are named by a point of attachment on the main chain. Also, I say alkyl, that means that is a substituent. They are groups of alkanes that are substituents off of the main chain. All of these little stars here mean that that is my main chain of carbons. So I have some long chain of carbons, okay, and off of that long chain of carbons, I have this. I would call that a butyl. If I had a long chain of carbons here, and off of that chain I had this, I'd call that iso. Because this carbon right here is a primary carbon. It's connected to 1 other carbon. This guy right here will be a sec-butyl because this guy right here is a secondary carbon connected to this carbon here and that carbon there. We don't count the main chain, which would be over here. All these carbons would be over here. Okay? Is a tert-butyl or a T-butyl? Because off of this chain that I have here, this carbon is a tertiary carbon. It's going to 1, 2, 3. Okay, there is one exception, and that's an isopropyl group. Okay, this is propyl because it is 3. These are all butyl because they're 1, 2, 3, 4. Okay, I have a main chain of carbons here. This should be sec-propyl because that carbon there is connected to 2 other carbons. So it should be a sec-propyl. It is actually called isopropyl. That's rubbing alcohol is isopropyl alcohol. Okay, structural isomers have different properties. And the number of isomers you have increases with how many carbons you have, how many different types of carbons you can have. Okay, so I hope I'm bringing this all together. You're probably really confused. I'll bring it all together. We're going to look at some examples. Okay, and hopefully that'll help clear the air a little bit. So I'm going to name these 3. All right. So the first thing I'm going to do with this one, first thing you want to do actually, is draw these structures. And you're just going to draw the top 2 for right now because I can't get that bottom one in the picture. So go ahead and draw those two structures. Leave room for one more. Okay, now we're going to go ahead in this first one in the upper left, and I'm going to find the longest chain that I can find. And the longest chain that I can find is not the straight one here, which is 1, 2, 3, 4, 5, but it's actually the one that is 6. 1, 2, 3, 4, 5, 6. So this is my main chain. So usually what I do is I'll box around it so that I know that's my main chain. Okay? And that means we're going to end in, when we name, we're going to end in hexane, because that means I have 6 carbons that are bonded singly, the ane. I do, though, have this little group off the side, okay, and this is that alkyl group that I was talking about with a YL in it. It's off of the main chain. It's got 2 carbons, 2 is less than 6, so it's not the main chain. Okay, so there's 2 of these, so that is an ethyl group, not ethane, but ethyl, okay? And now you know which carbon on the chain this ethyl group is connected to, so I'm going to count, okay? If I start here, I'm going to go 1, 2, 3. So if I started here, I'd be on the 3rd carbon. If I started down here, I would also be off of the 1, 2, 3, 4th carbon. So I want to start numbering up here because I want to have the lower number. So you would call that 3-ethyl hexane. That same reasoning, I'm going to go ahead and I want you to try the one next to it here. When you have these are just ending in an O. This would be bromo when you use that as a substituent. This would be chloro because it's chlorine. So go ahead and try and name that. Okay, so you should have found your longest chain, which was all the carbons, and it doesn't really matter which way you split. Okay, I'm split to the left, but it's not going to make a difference. It's going to be the same numbers either way. So I've got 1, 2, 3, 4, 5 carbons. So that should have been pentane. I've got all these substituents. Okay, tend to go in alphabetical order. Well, B is definitely first. Okay, these are all methyl groups because they are 1 carbon off of my main chain. I'm sorry, that's not a main. That one there is a methyl group because it is off the main chain. It is 1 carbon. So what we're going to have here, okay, I need to know which carbon that bromo is off of so I can number it. Well, 1, 2 would be off the 3rd, or 1, 2 would be off the 3rd. So it doesn't make a difference. Either way, all these substituents are off of 2, 3, and 4. So I'm going to start over here, call that 1. So I would be 3 bromo. Okay, I'm going to do my chloro one next. So 1, 2, 3, 4. So I'd be 4 chloro. This methyl group was next, so 2 methyl. You should put dashes in between there. So it's the name of this guy is 3 bromo, 4 chloro, 2 methyl pentane. Go ahead and draw this big one here, and then we'll go ahead and name that one. I'll go ahead and try and name that one actually. Okay, when you name this one, make sure you have a carbon chain of 9. So I've got nonane. I have all these substituents. Got the 2 in red here. Okay, that are going to be my ethyl groups because they're 2 carbon chains. I'm going to have the 1 here in green that has a methyl group. And then I'm going to have this guy over here that is 3 carbons. So I should be prop. Okay, but it's not in a long chain. It's branched. This carbon is connected to both of them. So this is the one that's different, or you'd think it would be sec-propyl because it's connected to 1, 2 carbons, but it's not. We actually call it isopropyl. Okay, and that's why you see an isopropyl here. All right, and then you see the methyl, and then you see my ethyl. Now notice how we have 2 ethyls, so it's di. And these ethyl groups just so happen to be off of the same number. So that's why you go 4, 4. It sounds redundant, but they can also, or often also be off of different carbons. So you've got to always number them. How do you know which way to number? You always want the lower numbers. So if I would start up here, I'd have 1, 2 as a substituent. So I'd have 2, 4, and 6 as my numbers. what the answer is. If I started down here, my substituents would be off of 4, 6, and 8. Well, 4, 6, and 8 are higher numbers. You always want the lower numbers, okay, not the higher numbers. So this name is 4,4-diethyl 6-isopropyl 2-methylnonane. Okay, the last thing we're going to do now is try and actually write some of these. So write the condensed structural formula for 3-ethyl 2-methylpentane. So pentane is 5. So I'm going to go, okay, I need 5 carbons. 1, 2, 3, 4, 5 carbons. I have an ethyl group off of the third one. So off of the third one, I have 2 carbons. Alright, each carbon has to have 4 bonds, so it's going to be CH3. It's just connected to 1, 2 things, so I need 2 more bonds to it, so CH2, so there's my ethyl group. I have 2 methyl, so off of my second carbon, we do a methyl groups are always CH3, because 3 bonds, 1 to each H, and then 1 more to a C. So now I'm done. I gotta go back and fill in all my H's. So, alright, this only has 1 other bond, the carbon next to it, so it should be CH3. This guy has a bond to 1 carbon here, another carbon there, so that's 3. So it's going to be CH. Okay, so this is 1 carbon, connection, that's 3, so this is CH. Only 2 things it's connected to, so I need 2 more H's, CH2. And then this is going to be CH3. If you can't do that in your head, go ahead and draw them all out, all the little lines, and that's the same thing as well. I've just been doing it for a while, so I can kind of just count. Okay, the last one is 2,3-dimethylhexane. So I've got a 6. So 1, 2, 3, 4, 5, 6. 2,3-dimethyl, which means off of 2 and 3, I have a methyl group. Methyls are always CH3. Again, remember the difference between methyl and methane. Methane is CH4 standalone. Methyl is off of a larger chain or group. So let's go ahead and fill them all in. This is CH3. These carbons in the middle only have 2 bonds, 1 to each other, so 2 more H's. Ones in the middle are always CH2, okay? Ones on the end are always CH3. This has 1, 2, 3 connections, so CH. 1, 2, 3 connections, so CH. So that would be my 2,3-dimethylhexane.